All right, good morning, everybody. So we're picking up the lecture from where we left off last day. And so at the end of the last lecture, I was telling you that Java has broadly two different kinds of types. There are reference types and there are primitive types. Now, for the time being, the distinction between the two types is not that important. It'll become more important when we talk about reference types in a week or so. But for now, I want to tell you about the primitive types. Okay, so Java has 8 primitive types. They all begin with the lowercase letter. The type for true and false values is Boolean. So the values for true and false are little t true and little f false. And those are the only two types of Boolean values. Right? So Boolean values represent true false values. The next 5 types, so byte, char, short, int, and long, are your integer types. So all of those types represent numbers that are integers. You might wonder why there's 5 different types. One of the big reasons is historical. So it's because of C, which Java was meant to be the successor to, or one of the intents was that it be a successor to C. And C has actually C has many more types than the ones that are shown here. Now, normally when you want an integer value, you're either using int, sometimes you're using long. And so I'll explain what these are shortly. Finally, you have your floating point types, which are your correspond approximately to real numbers. In Java, typically you reach for double, and you might reach for float sometimes. And I'll talk about the floating point types either in today's lecture or in the next lecture. Okay, so the difference between reference types and primitive types, again, just to quickly remind you, is that reference types store references to objects. They don't actually store the value itself. So in Python, when you write x equals 1, the number 1 is not stored, is not associated with the variable x. Right? In other words, x does not store the value 1. It stores some piece of information that lets the Python interpreter find an object whose integer value is 1. Similarly, when you write y equals 1.0, it's not the value 1.0 that's stored in y. Right? Y stores some value that lets the interpreter figure out, oh, there's some object whose value is 1.0, and the same with a string. All right, so primitive types in Java actually store the value itself. So if I write int x equals 1, it really is the value 1 that's stored in x. Similarly, if I write double y equals 1.0, it really is the value 1.0 that's stored in the variable y. When you have a reference type, it behaves the same as with Python. So reference types in Java should always begin with an uppercase letter. So a string, variable s in Java, stores a reference to the string. It does not store the string itself. Right? The string itself lives somewhere else in memory. There is other information associated with the string, but the language appears to provide it looks like when you write s equals hello, it looks like it's the object. It looks like it's the string hello that's being stored in s. It turns out that's not really what's happening. Right? Again, we'll talk more about this distinction a little bit later on, of course. Right? So for now, it's this stuff that's important. Right? For the primitive values or for primitive types, it's the value that's stored in the variable itself. Right? So there are implications of this. There are very important implications of this. So the way that the primitive types work in Java and in C and C++ is that they all occupy a predefined fixed amount of memory. Right? So this is important. It's fixed amount of memory. Right? So you can imagine that for a number, so for some integer value, the amount of memory it takes to store that value probably should depend on the number of digits in that number. Right? If you have a very, very long number, then it seems to make sense that would take more memory to store than a number, say, like 1 or 5 or something like that. Right? There's only one digit in those numbers. Seems like you ought to be able to store those numbers in a smaller amount of memory. The way that primitive values work in Java is that they all, an int always occupies the same amount of memory regardless of its value. Right? So it's finite. The different primitive types, they occupy different amounts of memory. So the difference between int and long is that a long integer has more memory, or has more memory associated with it. So you can store a wider range of values in a long than you can store in an int, right? And there's an implication with all of this, right? Because the amount of memory is finite, then all of your primitive types, they can only store a particular range of values, right? So in other words, there must be, if you're working with int, there must be some int that has the most negative value that can possibly be represented, and there must be another int that has the most positive value that you can represent, right? But there's only a finite number of ints that you can actually represent, right? And that's very different than what you learned in math, right? So in math, you know that there is no range for integer values, right? There is no smallest int. Sorry, there is no most negative int. There is no most positive int, right? There's an infinite number of these things. But because you're storing these on a computer, they're finite, and therefore they represent they have a finite range. So when you're using integers, int is normally the value that you reach for when you're working with integer values. The most negative integer value is roughly minus 2 billion, right? The exact value is not important. I'm never going to ask you for it. It turns out that that value, if you need it, is stored in this thing here. So there is a value called big I integer dot all caps min value. Okay. So when you see something in all caps, that's an indicator in Java that it probably corresponds to a constant of some kind, right? And in this case, that's exactly what it represents, right? It's the constant that is equal to the most negative int that you can represent, right? If you want a value that's less than this value, you can't represent that number with int. It doesn't exist. Right? Similarly, the value big I integer dot all caps max value is the most positive int that you can represent in Java, right? It's roughly 2 billion. If you want to represent a number that's larger than that with an int, you cannot. It doesn't exist. So if you want values that are smaller, less than this or greater than that, you have to use a different type. So you would use long in this case, right? And long also has a most negative and most positive value. If you need values that are outside that range, you have to reach for something else, right? And the something else becomes more complicated in Java. This is very different than the way it works in Python. Python, there is no built-in smallest or largest value for integers, right? The way it works in Python is that if you try to compute a value that's greater than, if you try to compute any integer value, as long as you can store that value in memory, it's possible to represent that value. Okay, so if you want to write that, when you write down a plain old integer number in Java, so like -1 or 99 or 98 or 0, that's what's called an int literal, right? So literal is just something that you can write down. Right? So -1 is an int literal, 99 is an int literal. You can write down literals using underscores to separate groups of digits if you want to. It makes it a little easier to read large numbers. It's not commonly done, right? But if you want to, you are allowed to use the underscore. So that's the literal 1 million. Java has other kinds of literals that are also ints. Right? If you know what binary, octal, or hexadecimal are, there are ways to write these down. If you don't know what these are, don't worry about it. No one's going to ask you about it here. Right? If you're interested in what these are, just search for them. You'll very quickly find out how to write these types of values in Java. All right, so you write down an integer number. Java thinks it's an int. Right? Now remember, there is a most negative and most positive value that you can write down. So if you write down a value that's less than that or greater than that, Java will complain. The compiler will complain. Right? It'll say something like that number doesn't exist or it can't be represented in the range of int. Okay. If you want to use long, then the way to write down a long literal is you write down an integer value and then follow it with a big L or a lowercase l. Right? The L indicates that it's a long literal. Right? So 99L would be the long value 99. All right, so when you're working with primitive values in Java, the thing to remember is that if you perform an arithmetic operation with two primitive numeric types, if you perform an operation with two numeric values of the same type, and they're both primitive, you always get back the same type as the two operands. So if you perform arithmetic with two ints, the rule is you always get back an int, right? Which seems sensible until you think about division, right? If you divide, say, 3 by 2, you would think you should get back the number of 1.5. That's what you get back in Python. In Java, that's not what you get, right? You get back some integer value instead. So when you do division with two int values in Java, you get what's called truncating division, right? Compute the value and then throw away everything after the decimal point. Right, so here's an example, x divided by y. So x is 1, y is 3. So when you compute 1 divided by 3, you get 0.33333. Throw away everything after the decimal point, you get 0. Right, so truncating division, discard everything after the decimal point. Right, division, multiplication, subtraction, addition work the way you think they ought to work. Right. Z divided by y is 13 divided by 3. So 13 divided by 3 is 4.33333. Throw away everything after the decimal point, and the value of result is 4. Right. X plus y plus z is 1617. Right. So you can use parentheses to force the order of x, to force the order of evaluation. Right. So everything inside parentheses has higher precedence, so it computes x plus y plus z. You get 17 divided by 3. That's 5 and a bit. Throw away the and a bit part to get 5. Right. Division with negative numbers works the exact same way. Minus 3 divided by 2 is minus 1. Right. Minus 1.5. Throw away at 0.5. Okay, so what happens now? The problem is that when you're performing arithmetic with values, you can easily run into the situation where the result falls outside of the range of int. Right, so I can add two values, and the sum might be greater than integer max value. Right, if you add two negative values, the sum could be less than integer min value. Right? Now, what happens in these cases? So what happens is that you don't get an error. You don't get any notification that something strange has happened at all. Instead, all that happens is the value wraps around to the other side of the range. So if we start out with integer max value, right, the largest integer that you can have, largest int value that you can have, sorry, right? And I now compute x plus 1. So when Java sees x plus 1, it asks the question, what is the type of x? Well, that's an int. What is the type of 1? Well, that's an int literal, so it's also int. So it sees an int plus an int, and it says, well, the answer must be an int. So max value plus 1, we can't actually represent that value. So instead, what happens is you add 1, so it wraps around to the other side of the range, and you end up with integer min value. If you start out with the largest value and add 2, right? So if I add 1, I go to integer min value. I add 1 again, that's integer min value plus 1. Right? So the sum wraps around to the other side and just keeps on going. Right? X plus 3, that's the largest value. Right? Add 1, that goes to the min value. Right? Add 2 more, and that's integer min value plus 2. So it's minus 2 billion and a bit. Right? That's also minus 2 billion and a bit. Right? And that's also minus 2 billion and a bit. Right? Where the bits are all different. Right? So you can add a positive value and a positive value in Java and end up with a negative value. Right? That is possible. Right? The exact same thing happens on the other end. If I start with integer min value and subtract 1, right? Well, there is no value less than integer min value, so we wrap around to the other side, and now we're at integer max value. Right? Negative value minus a positive value ends up being a positive value. X minus 2, well, that's the smallest value. Minus 1, so I have the largest value. Minus 1 more, and that's the second largest value. Right? And similarly with minus 3 and minus 4 and minus 5 and so on. It just wraps around and keeps on going. The same thing happens with multiplication, although it's more complicated to figure out what the result is when you multiply two values. Right? The result wraps around and just keeps on going. Right? This phenomenon is called integer overflow. Right? So integer overflow occurs when an arithmetic calculation with an integer type results in a value that is outside of the range that can be represented using that type. Right? So in languages like Java and C, C++, C#, I think, wrapping occurs. Right? So you don't get an error. You don't get any notification that something strange has happened. Right? You just get a value back. Right? So wrapping occurs in Java. There are other languages where something else happens, right? So no wrapping occurs in Python because Python doesn't have any built-in limits on its int type. Right? There are other languages where you will get an error will occur when overflow happens, right? So the safety critical languages or languages that are used in safety critical applications might raise some kind of error, right, to indicate that overflow has occurred, right? Now you might think that, well, this is never going to happen to me. Right? But it turns out it does happen in everyday life. And in fact, it's happened a whole bunch of times. There's 6 examples of when it's happened. And so it's useful to look at these. So Ariane 5, for those of you who have not heard of it, Ariane 5 is the current generation of the European Space Agency's rocket. On its maiden flight, so the first flight where they tried to launch a rocket into space with a bunch of satellites in it, the rocket crashed shortly after liftoff. Right? When they went to find out what happened, they found out that the launch ended in failure due to multiple errors in software design, one of them which was integer overflow. So what happened here is that they took the code for the old rocket, which was much smaller, used it in the larger rocket without sufficient testing. Right? The larger rocket produced larger thrust values. It turns out these thrust values overflowed one of the variables that were used to store some value related to the thrust, and that caused a problem. Right? The rocket shut down and crashed. This one cost, there we go, $370 million. Integer overflow. Right? There's a bunch of these. There's another spacecraft. So this is Deep Impact. So this was a NASA satellite that was sent to an asteroid. It was meant to land on the asteroid. Let's see. What happened here? It didn't work, right? According to Chief Scientist A. Hearn, the reason for the software malfunction was a Y2K-like problem. Something, 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 some integer value. Oh, here it is, sorted an unsigned 32-bit integer, which then overflowed, causing the spacecraft to malfunction. Right, that's another expensive, very expensive, very expensive result of integer overflow. Somewhere in this article, it tells you how much it cost. Therac 25 is a sad Canadian story. Sorry. Okay, Therac 25 was a radiation, medical radiation device. So uses radiation to treat some sort of, typically it's cancer, but it's meant to kill tissue inside the body. So they're shooting radiation into the body. Okay, and so what caused, this was a Canadian machine. I forget when, 70s or 80s, sometime back then. When they went to find out what went, it ended up killing 5 or 6 people, I think. Several people anyway, because it overdosed them with the radiation. They went and looked at what happened. Turns out there's a whole bunch of stuff that happened. One of them, where'd it go? Somewhere in here, it's an overflow. Here it is. So the software flag set a flag variable by incrementing it, so it adds a numeric value to it, rather than setting it to a specific value. Occasionally, arithmetic overflow occurs, causing the flag to return to 0 and the software to bypass all safety checks. Your GPS systems, they all have an integer overflow bug in them. So your GPS systems use a use a 10-bit number to store the weak number. If you use 10 bits, the range of values that you can store are between 0 and 1023, right? So if it's storing the weak number after week 1023, well, there is no 1024, so it goes back to 0. If your GPS receiver, or if your GPS system's not set up to handle this result, you end up with a funny result. Right? So there's another overflow problem. Year 2000, most of you are younger than this, so you may not have heard of it. Yeah, most of you would not have heard of this because you weren't born then. So the year 2000 problem occurs because prior to the year 2000, many software systems stored years using only 2 digits. So the year 1995 would be stored using 95. Right. One of the reasons this happened is because banks started using computing in the 70s or 80s. Memory back then, very expensive. So it's useful, instead of to store the date, you only have to store 2 digits instead of 4, right? You have the amount of memory that you needed to store a date. This turned out to be important back in the early days of computing. But all that software just kept on running and running and running. And then when you hit the year 2000, you now have a problem, because the year 00 is either 1900 or 2000, depending on the context. Right? It's 1900 if you happen to be born in 1900, right? It's 2000 if you're trying to do something else, right? And now you have an error of 100 years in your banking software, which causes all sorts of problems. Not just your banking software, any software that keeps track of your year with only 2 dates. So we spent a whole bunch of money trying to fix this problem. No one actually knows how much money was spent. It's in the billions of dollars. It's thought to be in the billions of dollars that was spent trying to fix this problem. Fortunately, nothing disastrous happened. The exact same thing is going to happen in 2038 because of the way that many computer systems store time. Many computer systems store time by counting the number of seconds from January 1st, 1970. Eventually, they're going to run out of the type that they're using to store the number is going to overflow in the year 2038. The exact same thing's going to happen as the year 2000 problem. So these sort of bugs, or these sort of integer overflow bugs, do occur in real software. They will occur to you at some point, whether you know it or not. Okay, so watch out for integer overflow. If you're doing something with real numbers, then normally in Java, you pick the value double. So double is your choice for calculations involving floating point values. So floating point just means anything that corresponds approximately to real numbers in math. Now, the floating point values work a little bit differently than the integer values. And so the largest double value that you can store, you can get that value by looking in the variable big D double dot max value. This turns out to be a very large value. So it's on the order of 10 to the 308, right? Which is enormous. There is no corresponding constant for the minimum value, for the most negative value. Instead, the most negative value is simply the negative of high, right? So minus 10 to the 308 to 10 to the 308 approximately is the range of double. You have to be careful with this, because if you try to use double dot min value, the same way you use integer dot min value, right? It turns out double dot min value is something else, right? It's the smallest positive value that you can represent, right? So the smallest value that's greater than 0 is stored in double dot min value. So when you write down a number with a decimal point in it, so 1.0 or 2 dot, or 1,000,000.99, these are all examples of double literals. So if you write down 1.0, Java thinks that's a double value. Right. Now there is a smaller floating point type, so a type that represents a narrower range of values called float. If you were to write 1.0f, that becomes a float literal in Java. Right. We're not really going to use float in this course, so you only really need to worry about double. If you try to write down a value, a literal that's larger than whatever double max value is, the Java compiler will flag that as an error. Okay, so the one weird thing that you have to watch out, the one unusual thing that you have to watch out for is this format called scientific notation. So this is common in scientific and engineering applications. When you write down a floating point number, it has this funny E in it. So what the E means is times 10 to the power 6. Right? So number E, some integer, means that number times 10 raised to the power 6. The number here after the E has to be an integer. Right? So you can't write E 1.5, for example. That won't work. Right? So this is just a short form to write times 10 to the power to some integer power. This does not have to be 1 point something or 0 point something. It can be any number here, and then E followed by any integer value there. Just like with int, if you use two double values to perform an arithmetic calculation, you get back a double value. So x plus y, x is a double, y is a double. 1 plus 3 is not surprisingly 4.0. Right? Division works the way you want it to. Right? X divided by y, 1 divided by 3 is 0.3333 something. Right? Z divided by y, so 13 divided by 3 is 4.3333 something. Again, you can use parentheses just like you can in math to control the order in which things are evaluated in. Okay, double or floating point values do not overflow. Right? So wraparound does not occur when you use two double values. Right? If you use two or more double values to compute a value that's outside the range of double, you end up either getting positive or negative infinity, right? Depending on which end your value exceeded. Right? So the value double dot positive infinity is the value that corresponds to the positive infinity. Double dot negative infinity is the value that corresponds to negative infinity. Right. So the largest double value is roughly 10 to the 308. Right. So if I compute 10 to the 200 times 10 to the 200, that's 10 to the 400. Right. That's larger than the double max value. So you end up with positive infinity instead. The smallest or most negative value is roughly 10 to the 308. Right? So this is -1, so negative 10 to the 400, which ends up being double dot negative infinity instead. Right? Wraparound does not occur with floating point values. Right? Instead, we get what's called saturation. Right? Values saturate at positive and negative infinity. The same thing happens in Python. Right? So Python's float type corresponds to Java's double type. Okay, so that's the quick tour of the built-in types, the built-in primitive types, right? So integer, and int and double. All right, there's more differences that you need to know about between Python and Java. Right? So Python has user-defined functions. Right, so remember what a function is. Oops, sorry. Remember what a function is in Python? It's just a procedure that has a name. It has some inputs. It might produce an output. Right? And so it represents a reusable chunk of code that you can call by name. Right? It's parameterized, so you can pass in different values to have that chunk of code operate on different values. Right? So here I've got a function called max2. This is meant to work on numeric values. There's no way to specify in Python that A and B have to be numeric values, though. So when you call this function, you have to be careful to pass in numeric values. Right? It's going to compute the larger of A or B without using an if statement. Right? So it's going to do it in a very strange way. Right? It's going to compute A plus B. It's going to add the absolute value of A minus B, and then it's going to divide the result by 2. And my claim is that this produces the maximum of A or B. If you sit down and work this out mathematically, you might be able to convince yourself that this is in fact true mathematically. Right? Now, if you've been paying attention to what I told you about ints, though, or doubles, you're going to realize that when you actually compute this in Java, you're going to run into a problem. Right? If that sum or that difference overflows, something weird is going to happen. This is not going to give you the right answer. Now to call this function, right, if it's defined in a module, you import the module and then you call the function by name, right? Passing in two appropriate arguments. Okay, this is how it works, right? So we're going to compute the sum a plus b and then add the absolute value of the difference, right? So here's a, here's b, right? I want to know what is the larger of the two, right? You can switch them around. So this could be b, this could be a, right? It doesn't matter. Right? So what is a plus b divided by 2? That's just the average of a or b, right? Where is the average located? It's located exactly halfway between a and b, right? It doesn't matter if that's a or b, or if that's b or a, right? The average is exactly halfway in between, right? What is the difference, or what is the distance between these 2 points, right? It doesn't matter if which one's a, which one's b. If you compute the difference and take the absolute value, that gives you the distance between these 2 points, right? So if I start at the middle and add half of that, I end up on the right-hand side, or the largest value, regardless of which value is a or b, right? So if I take the average value and add half the difference between those values, I end up with the maximum value. So mathematically, this always works. Okay. Java has no functions. So that's the first thing to remember, right? If you want to write something that corresponds to max2, exactly the way that Python writes it, you can't, right? You have to do something else. So in Java, the closest analog to a function is what's called a public static method. Right? So the method, it's similar to a function, but in Java, everything has to be inside of a class or something called an interface. So now, just to create something that looks like a function, I have to make a class. Right? So here I've got public class lecture 2, even though it's lecture 3. Right? Here's my thing that looks like a Python, sort of looks like a Python method, right? And sorry, sort of looks like a Python function, right? And this is the corresponding method in Java. Right? So let's take this thing apart one piece at a time. Well, let's call it first. So to use max2, it becomes a little bit more complicated as well, right? So if this class lecture 2, this class lecture 2, I might have to import it depending on where that class is located to my class test lecture 2. Right? I should probably get rid of that. That's actually never going to work. That'll never work. I have to update this slide. So to use the method, what you define inside of another class, you might have to import the other class. Right? Once you've imported the other class, when you call the method, right, you need to use the name of the class to call the method. Right? So instead of writing max2, I have to write lecture2.max2. Right? Name of the class, followed by a dot, followed by the name of the method. Okay, so when I'm going to tell you what all the individual pieces of this thing mean in just a second. So in Python, you use indentation to denote the block of the method. Right? So for max2, the body of the method must be indented. Right? The lines have to be indented by the same amount. If you're using spaces, you have to use spaces. If you're using tabs, you have to use tabs. Right? You can't mix the types of indentation. Right? And Python does this in a lot of places, right? So it does it for functions, it does it for if statements, for loops, right? The body of all of these things are always indented. Java does not use indentation. So indentation in Java, as far as the compiler is concerned, is unimportant, right? Indentation in Java is only used for readability. So your compiler doesn't care if your code is indented, right? But when you write your Java code, you should make sure that your indentation is consistent, and you should follow the examples that are in the slides and in the class notes to format your code. Right. So, for example, here I can rewrite that entire lecture 2 class. Right. So notice here it's nice and readable. Right. Here's my class. The method is indented one level. The body of the method is indented another level. Right. The language itself doesn't actually care. You can write it however you want, as long as you have space where there needs to be space, everything's fine, right? Notice this is very hard to read. I think everybody will agree, right? Don't write your code like this. Write it like this. Okay, so if we're not using indentation, what do we use instead? Right. So Java uses braces or a matched pair of braces to define what's called a block. Right. So here's my class, and then the class body is inside of a pair of braces. Right. So all of the contents of the class have to go inside the round braces. I then have my method. So here's my max2 method. The code for the method all must be inside of a matched pair of braces. Right. And so braces in Java denote what are called blocks, right? And we're going to see blocks over and over and over again here in this course. Right. So instead of indentation to define blocks, right, it's braces that explicitly define blocks. Oh, I'm sorry. Next lecture. So we're on to the next deck of slides. So this will be number 3. And I think that this one starts back a few slides. Yeah, it starts back at the double. So, okay, so we're here. Okay, so for the time being, when you make a class, make it public, right? Later on, we're going to change the word public to other, or I'm going to show you what other things that can be. For now, everything is public. So public in front of the word class is what's called an access modifier for the class. Right? So an access modifier simply determines where the class lecture 2, what is it visible to? Public means lecture 2 is visible to all other classes. And there are other access modifiers that you can use here. For now, everything's public. Also, for the time being, all of our methods, this is only going to be true for like a week, right? For the time being, all of our methods are public, and as well as being static. So public on a method means that the method is accessible to anything that can see the class. Right? So if our class is public and if our method is public, that means the method is visible to all other classes. What does static mean? All right, so static means that the method, max2, is associated with the class lecture2. Right? So static max2 belongs to lecture2. Right? So that means that when you call the method max2, you must also use the name lecture2 in front. Right? So lecture2.max2 will call the max2 method. Later on, we're going to get rid of this word static. When you get rid of the word static, you now need an object reference to call the method. Right? So I now need an object whose type is lecture2 to call the method max2. For now, everything's static. Use the class name to call the method. Another difference between Java and Python is that all variables in Java have a type. Parameters are just variables that belong to a method, right? So A and B, these are just variables that belong to the method max2. They're variables, so they need a type. Now, unlike the Python function, where you can pass in 2 ints or 2 integer values or 2 float values or any 2 numeric values and the method will work, that's not the case in Java. Right? In Java, I have to pick a type for A and B. So here I'm going to pick int. Right? So my max2 method is only going to work for int values A and B. Right? If I want it to work for double values, I have to change these types, or I have to make another method that works with double values. Right? So for now, we're going to work with int only. So our parameters also have types. Right? The parameters are visible inside the block of the method. So the names A and B are usable only inside the method max2. All right, so another difference between Java and Python is that in Python, a function never says whether it returns a value or not, right? It's def, function name, function parameters. Right? In Java, you have to say whether or not the function returns a value. Right? The other difference is that in Java, if your method returns a value, it can only return 0 or 1 values. Right? Unlike Python, you can return a tuple of values. Right? So you can return as many values as you want, you just return them in a tuple, which is really convenient in many cases. Java has the restriction, you either return nothing or 1 value. If it returns a value, you have to say what is the type returned by the value. So our method max2, right, returns an int, right? Takes in 2 ints, determines which one is larger, and returns the larger value, right? So it's public static return type, method name, round brackets, parameter list. Right? So our max2 method returns an int. If you remember back to the previous lecture, we had a main method. Right? The main method is where your program starts running from. Right? A main method doesn't return anything. So if a method returns nothing in Java, you use the word void to indicate that. Right? So public static void main means that the method main returns no value. So your Java methods must say whether or not they return a value. If it doesn't, it's void. And if it does, it's the type of value that's returned. So like Python, if you have a method that's going to return a value, there has to be a return statement somewhere in the method. Right? So the return statement in Java does the exact same thing as a return statement in Python. It returns a value back to the caller. Right? The method stops running immediately after the return statement. So here, I'm going to return twice max divided by 2. Right? The value that you return, right, that type there, must match the type that's back here. Right? It either has to match or be compatible with. Right? Don't worry about what compatible with means right now. Right? So for the time being, whatever value you're returning here has to be an int of some kind. Right? Twice max is an int. Right? 2 is an int. Remember what I told you at the beginning of the lecture, an int divided by an int is always an int. Right? So as far as Java is concerned, that's returning an int, which is good, because as the programmer, that's what we said it would return. Right? We said it would return an int. So void statements, void methods that return no value, have no return statement. Right? They don't return a value, therefore there's typically not a return statement here. You are allowed to put one in if you want to. So you can put in the empty return statement, return semicolon. That basically ends the method at this point here if you want to. This is occasionally useful if you have an if statement. So if some condition is true, return to indicate the method should end. Right? Otherwise, do something else. Right? Here, it's not very useful, but you can put one in if you want to. Okay. So this is a more sensible implementation of max. Right? So this one computes the max of 3 values. So this uses an if statement to compute the maximum value. Right? So if I want to compute the maximum of 3 values in Python, I can use an if statement that looks like the following. Right? So if A is greater than or equal to B and A is greater than or equal to C, I know that A is the largest value. Right? So I can store the answer in result. And at the end of the function, I'm going to return the answer. Right? Else if B is greater than A and B is greater than C, I know that the greatest value must be B. If neither of these conditions are true, then I know that the result must be C, right? And I can return the answer down there, right? So this is one of many, many different ways that you can write max3, right? You're going to see in a second, there's a bunch of other ways you can write this, and I don't even show you all of them. Okay, so how do you write this in Java? All right, so remember, there are no functions in Java, so I need a method. So I actually need a class, which I'm not showing. Right? But you need a class, then I need a public static method. Here I'm going to use write a method that works with double values. So it's going to take in A, B, and C. They're all double values. Right? It's going to return a double value. If I'm going to write this in the exact same way as the previous slide, there has to be a different, I have to make one change here. Right? So up here, I need a variable called result. right? In Python, oops, sorry, right? Where'd it go? Where's Python? Here we go. Right? In Python, you never declare variables, right? If you need a variable, you just make it up and use it right away, right? So here is the declaration and definition of result. In Java, you have to declare a variable before you can use it, right? So here, I'm going to declare a double result as being a double value here. I'm not going to give it an initial value. Just let me quickly jump through. Okay, so I'm going to explain all of the differences here. Right. All right, so we now have our if statement in Java, which superficially looks similar to the way Python, to the way the Python if statement looks. Right, I've got if, then I've got round brackets and some condition inside the if inside the round brackets. Right. Notice that there are some differences here. Right. There's no and or no, there's no word and in Java. The and operator in Java is the double ampersand. Right, so ampersand is the logical and operator. Right? Remember, Java has no indentation for blocks, so I need braces here. Right, so the body of this part of the if statement goes inside of braces. Right, instead of elif, it's else if in Java. Right, else is the same, so that's good. Down here, I can return the result, so that's the same as in Python. I am going to explain all the differences here in detail as we go. Right. Just like in Python, you can get rid of the else clause. Right. The else clause here is the, I guess, the quote unquote default answer. Right. So let's assume the answer is C. So at the beginning of the method, at the beginning of the function, I can assume the answer is C. Right. Then I can ditch the else statement down here, or the else part of the if statement. And this is still the exact same thing in Python. Right? In Java, exact same thing. Right? So double result equals C says that the variable result is a double value and it starts with the value C. Right? So in Java, this is declaration. Right? Declare that the variable exists. Right? And if you do that, and if you give it a value where you declare it, this is called initialization in Java. Right? So that statement there initializes result be equal to the value C. Right? It turns out this is different than writing double result semicolon, and then on the next line writing result equals C. Right? If you write it that way, the result equals C is called assignment, right? Not initialization. This is initialization. That is assignment. So there is a difference in Java. Okay, so conditions in an if statement in Java must appear inside parentheses. Right? Python, you can put them in parentheses if you want to. In Java, they must appear inside parentheses. You can use additional parentheses inside the parentheses if you want to control the order of operation. Right? The greater than equal to, same as in Python, right? Less than or equal to, same as in Python. Okay, the scope of a variable is the region of code where a declared variable name is usable. So this is Python doesn't really have this notion. Well, it sort of has. It has a notion of scope. For most beginner programmers, you don't actually recognize that this scoping thing exists, right? So scope in Java is important because it determines where can you actually use a variable. So in my method here, I've got some parameters A, B, and C. Right? The scope of these parameters is the body of the method. Right? All that means is that the names A, B, and C are usable anywhere inside the body of the method. When I say double result here, right, the scope of result is from this point to the end of the block that it's defined in. Right, so result is usable up to this point here, right? I guess this point here. Right, so why did I have to write this method by writing double result equals C here and result equals A here, instead of writing it like this? Right, so remember in Python, I just wrote result equals A, result equals B, and result equals C. Right, the problem in Java is if I write double result equals A here, right, what is the scope of A? Right? Or what is the scope of result? Sorry, what is the scope of result? Well, it's from the point of where it's declared, so here, to the end of the block that it's in. Well, the end of the block that it's in is here. So the name result does not exist outside of this block. Right? So when I try to return result down here, the compiler says there is no variable named result. Right? Similarly, if I write double result equals B here, right, the scope of this result is the point at where it's declared to the end of the block at which it's declared in. So again, when you try to return result, the compiler says there is no variable named result, and you get an error. Right? So that's the reason why we have to write our code this way. It looks like I'm out of time. So we'll pick this lecture up in 2 days from now.